Hi, everyone. Hi, good people there. Good evening, everyone. Welcome back to the series of the project presentations from 360 Digit MG in association with Innodatatics. As part of our previous discussion, we had a quick look at how we can estimate the performance of an employee. We talked about the performance appraisal cycles that the organization has, which is more like a reactive approach. The entire year's effort, every organization has its own strategies. A few companies also have half-yearly review or quarterly review of employee performance. But generally, the appraisals, the rise in the salaries and the promotions that the employees generally get is assessed for the entire 1 year's efforts. So if an employee is performing well, then obviously the promotions and whatever the increments that are defined as per the commitment from the organization, they will be getting the the employees are going to get those benefits. But as I said, this is reactive. What if the employee's performance is declining? Could be various factors influencing that. But over a period of time, when you look back and see that, okay, after 1 year, we are reviewing the performance of the employee, and we find that the employee is not at all proactive. So it's completely reactive efforts. After the assessment, that's when the organization or the HR team realizes that the performance of a specific employee employees is declining, and they need to take an appropriate steps. Now, this model is proactive approach in which it constantly looks into the data which is available or which is acquired from HRIS or HRMS systems that the HR people generally use in the organization, and the various metrics that are keep on adding into the system. Using those metrics, the model tries to predict upfront on the performance of an employee. Now we can define the interval of the assessment on quarterly basis, monthly basis, or even for daily basis. And we will be able to upfront flag if the employee's performance is declining with respect to the maybe certain thresholds that the organization or the HR team might define. If the performance is declining beyond a specific threshold, then immediately there should be some kind of a proactive strategic decisions to be taken, which would try to motivate the employee in different ways. This is going to have an overall benefit to the organization to ensure that there is consistency in the productivity of the overall organization. Of course, the employee's productivity is directly proportionate, right? Your organization's productivity is depending on the employee's productivity. So we are ensuring that there's consistency maintained in the productivity of your employees. So the objective of this specific project is to try and maximize the performance of an employee. And as part of this objective, we try to do a prediction model wherein we'll try and identify who are those employees whose performance is declining. And of course, there are various factor analysis techniques that are also included, which basically allow the HR team to specifically target the factor which is negatively impacting the performance of the employee. The challenges that we had to face, especially with respect to developing or analyzing this business problem, is the availability of the relevant data. The challenge was with respect to the COVID conditions, specifically because of COVID conditions, the tracking of the employees' performance was a little challenging aspect because people were asked to work remotely. There are not many, or in fact, based on our research, we found that there was no product which is actually being used by the companies which can track end to end for the employees, remote login and their productivity. There's no tool as such which can be used to monitor the employees. So that was the biggest challenge that we had to deal. The product that we were trying to develop was an approach to generalize the solution for different organizations, different types of organizations, irrespective of the domains. Though we had targeted the IT companies, but we also wanted the product to be generalized for all the other domains as well, like retail, like manufacturing, like logistics, supply chain, right, finance, all the domains. But again, the challenge is the nature of these businesses and the way the employees operate in this individual sectors. So finding a common set of variables was another challenge. Of course, the approach that we have taken is to segregate the business based on the domains, and based on that, we try to develop the model specific to each sector separately, because the variables, the features that we had to choose were slightly different for different sectors. Though, as part of our discussion here, we'll not be going into those details in details of other domains as well. But at a high level, we will be showing you on how the code has been developed with respect to doing some predictions on the performance of the employee. We follow CRISP-MLO methodology, and we emphasize on automatic implementation, or I should say automatic development of the machine learning workflow. So when we were developing this ML workflow, we try to ensure that we can use as much as possible the automated libraries. The CRISP-MLO is the standard process that is used in developing the ML products, ML applications. This ensures that there is the standard process which can be implemented in any sector with respect to utilizing the data that the sector is generating and developing the machine learning models. The biggest, or I should say the most time-consuming area in this 6 phases of CRISP-MLO methodology is in this area. We'll start here. The second point that you are looking at here, which says data pre-processing, data engineering, will contain, of course, many aspects. It starts with respect to, if I have to say, let me not write 1 here, let me say 2, data pre-processing. One of the thing is integrating multiple softwares so that the data can flow through these sources into the processing tool. Of course, there were many sources where the data gets generated. For any business, if you see, there will be multiple data sources. So we needed to integrate these multiple sources into the Python so that we can collate all the data and then do the processing. So the first challenge, or first step, I should say, is integrating different softwares. Then data ingestion, we had to collect the data. And then we talk about transformation of the data. So it's like a ETL tool that we are speaking about, the ETL tasks. Extract, transform, and load. So we are doing transformations here. Right? And of course, the loading part is coming at a later stage. But whatever the data that we have gathered for pre-processing was to ensure that it does not have any challenges, I would say. There shouldn't be any missing data. There shouldn't be any exceptional data. There shouldn't be any data which cannot be used for mathematical model developments and all that. So there are a bunch of things that we'll have to look at. There are close to 8 to 9 checks that we need to do. And this has to be done for each and every data point that we have collected. So this is going to be a time-consuming task. So we had to clean, pre-process. If I have to put this step pre-process, then it's cleaning, it is organizing the data, and you can also say we needed to transform the data from one form to another form. And there are a bunch of other things that we will do, like feature engineering and all that. So as I said, this step is the most time-consuming step. Now, thanks to certain libraries, which allows us to ensure that all these checks are automated. So we are using something called as auto EDA libraries. I will show you the demonstration of these libraries. Whatever the libraries that we have used, right? We'll demonstrate on how these libraries work. Then we also had tried auto ML implementations. That is basically coming at the third step. Because in the ML workflow, there might be many machine learning models that can be implemented. As part of the demonstration of the code, we will be showing you the manual ways to run different codes. But there are auto ML libraries which can be used, which will help us to automatically try all the possibilities and then give us the best result. Right? Though for today's session, we will be doing it manually, as I said. And along with the model development, another time-consuming task is tuning of the model. Whatever the model seems to be working better, we will have to further fine-tune it to ensure that it gives the best result. And when we talk about tuning, again, this tuning is a very, very time-consuming task because every parameter that we change, right? We call them as hyperparameters. Every parameter that we want to target and change, right, will generate a different model. We call them as experiments. So there could be hundreds and hundreds of hyperparameter tuning opportunities that we might see. We may not be able to manually rerun the code hundreds of times. So this is another area where we used automated techniques. Hyperparameter tuning techniques. There are many approaches, many options that we can try out. And this is also something that we try to automate. And machine learning workflow is tending towards automation area. So we also had tried to develop the entire application ML workflow using these automated tools. And for the deployment stage, as part of today's session, we will be only showing you the Flask application. Flask is Python's library, which will help you to get a web framework installed. It's called as a lightweight web framework library, which will allow us to generate HTML pages, which can give us the UI, the user interface for the application that we have developed. UI for the application. Now, when you are trying to implement this in production, of course, we cannot demonstrate the production deployment as part of the session because of various constraints that we have from data security perspective, access perspective, and NDA clause perspective. But when we try to, you need to understand the concept. when we try to deploy the entire solution in a production environment, we need to ensure that CI/CD pipelines are implemented. Along with this, we also need to have CT. CI stands for continuous integration. That means there should be all the systems integrated continuously without any breaks so that the data flows through the system. Continuous development. This basically speaks about the model continuously being developed, enhanced, monitored, right? And then continuous training is specific to your machine learning workflows because your model is directly proportional to the quality of the data that we are working with. Any machine learning model that we speak about is directly proportionate to the data that we are using. The data that we will be using for developing the application will always be a sample data. But when it is being productionized, we will keep on getting new data in the system. And when there are drifts in the businesses, when I say drifts, the objectives, the visions, the goals of the organization will change, keep evolving, improving. So the way the business is run, the way the management drives the businesses will alter. This drifts in the business will also cause drifts in the data. So if data is changing, the model obviously will not work the same way that you expect when you are using the older data, old version of the data, while you are developing the application. So we need to constantly ensure that we monitor these drifts in the business, in the data, and probably in the objectives of the business also. And then accordingly, we try to constantly keep training and developing your application on the new data that is coming in. Thanks to the continuous integration step, we will be able to directly use the new data as well. So these are the three things that you'll have to focus when you are trying to productionize the environment. These are basically the architecture, the project architecture. We have discussed this in our last session. We've used SQLite, you can say MySQL in fact. Then we use pandas and we try to extract the data from the HRIS systems, which is ultimately our relational database systems. And then once the data is obtained into the processing tool, that is your Python, then we used various libraries to do the EDA, auto EDA steps. And then once the analytics is performed, once the preliminary insights were derived, we went on to next step, which is machine learning model development. And these are some of the models that we have built. For the prediction models, along with after the analytics is done, the factor analysis and all those things are done, the prediction model was to identify an output, which is the performance metric. And this performance metric ranged from a scale of 1 to 10. And this is a continuous outcome. It could be decimals as well. Because it is numeric and continuous, we had to use regression models to do the prediction of this output variable. And you can see these bunch of options that we had used. And we also did hyperparameter tuning. And then finally, the best model was used for deployment, and we used Python Flask for deploying or creating the UI so that the end user, that is HR team, can probably use that particular model. Right, and yeah, this is the data set. We had 29 columns, 5,000 rows approximately. And then we built the model. Let me directly go to the report. Yeah, these are the various models that we discussed. And the best results were obtained when we were discussing, when we split the model on 80-20 proportion. So we had to do this experimentation with splitting the data into different proportions as well. And you can see the performances here. There were certain models which were overfitting, like decision tree regressor. You can see the accuracy is 1. Right, so this is overfitting model. Right, so we had to try and use various hyperparameter tuning techniques to ensure that these things are properly right, taken care of. And finally, we used the random forest regressor, which was giving us a little better accuracy with respect to the test accuracy, which is used for generalizing the performance of the model. The deviation or the difference between train accuracy and test accuracy with respect to random forest regressor model was less. So we used random forest regressor. And finally, we basically had right, deployed the model using Flask application. Let us now move on to look into the code. And for discussing purpose here, we will be using Jupyter notebooks. The entire development was done using Python programming language, and the IDEs were either Spider or Jupyter notebooks. There's not much difference between them. Each of it is right, having its own capabilities. For our discussion, we will be using IPython notebooks for now. So let us look into the deployed outcome. I'll ask my teammate here to share the screen so that we can see how the outcome looks like. Yeah, Kiran, would you please mind sharing your screen, and let's see how the UI looks like. Can we go to the deployment? Yes. This is for demonstration purpose only. Very basic UI has been shown here for you people. And this, as we discussed, is the model, which is local deployed, right, using Python Flask library. And if you can scroll down, there are a bunch of features that were asked to the HR member, whoever is the end user. The end user needs to fill in these factors, and when we keep doing that, yeah, you can fill up the random numbers. Yeah, random numbers can be good. And then we can click on the predict button here. When we click the predict, it gives us the UI. You can see the result here. The performance of an employee is being satisfactory. Employee has satisfactory performance, 2.7 on a scale of 10, right? We cannot use negative words, so we said satisfactory. But this is an alarming situation. So we had to share this kind of information, right, to the HR people, or HR people who are using the system can take right, note of the performance of the particular employee, and these results are getting stored back into the database so that dashboards can be created to show how the right trend, what is the trend, or what is the improvement or the declining in the performance of that particular employee can be accessed. For each and every employee, we will have a report on how the right performance is being over the years or over the months. So let us now go into the code. All right. So you can see Jupyter notebook there. We followed the performance metrics prediction model. This is the model that we had to develop. And we used CRISP-MLO methodologies, which has 6 phases, starting with the business understanding. And the objective for our project is to ensure that we predict the performance of the employee so that we can use that information to proactively take decisions with respect to motivating that particular employee whose performance is declining. The data is stored right in an RDBMS system. You can see we use the library MySQL.connector to connect to the data and then retrieve the information that is required. Okay, this is a dummy data set that is being shown here. The actual production environment will not be able to show the username, passwords, and all that. This is only for demonstration. So you can see the username, password being given there. We need to mask, of course. There are different techniques that are used to mask the passwords also. But yeah, we need to connect from Python to database in order to get the data. Using my cursor object, we retrieve the information. You can see here below the data. Right, and using the pandas library, we ensured that we capture this data into a proper data frame. And these are the bunch of fields that we have captured from our database. It includes employee ID, of course, the age, gender, the marital status, department, work-life balance. You can say what number of working hours, whether the employee is doing overtime, when did the salary hike happened, how much is the percentage of salary hike, etc., etc., etc. So these are a bunch of the fields that we have captured, in total 29 columns, as we discussed. And you can see these are the data types. So we start here with EDA, starting to understand what is the data type that your Python has identified. Dynamically, Python identifies the data type using pandas library. We have to assess whether this is fine. And yeah, you can see all these fields. Now to move forward to look into the EDA, again, we have used a bunch of libraries. The basic libraries which are used for data pre-processing includes NumPy, Pandas, Matplotlib, Seaborn. Then to capture the metrics, we used a sklearn submodule called metrics itself, and it has mean squared error library. We imported that. We also used cross-validation score. Then we used Python collection called counter. This allows us to identify the number of times a specific value is repeated. And for displaying, we used IPython code display library. For Seaborn representation, we use the style dark grid. Then in order to do the EDA, as we mentioned, auto EDA technique was used. And for here, demonstration purpose, you can see SweetWiz is the library that is being shown. Very simple library. All you need to do is install the SweetWiz library using pip or Kunda tool. We can get the library installed on our environment. And then we say analyze. All we have to do is pass the data set, and SweetWiz library is going to handle all the EDA that is required for each and every column of your data set. There are in total 29 columns, right? Out of which you can see 7 numerical values are there. The summary report is being shown there. There are no duplicates. The total memory consumed by this data set is 2.4 MB. The total features are 29, out of which 22 features are categorical, non-numeric features. And only 7 columns are numerical features. And if you click on associations, it gives us the results. You can see each column is being analyzed here. Missing value percentage, distinct values, then the preliminary statistical calculations with respect to data distribution identification, max, median, minimum, IQR, variance, standard deviation, all these calculations are done. Now, of course, employee ID can be ignored from our analysis. You can ignore that particular column, but you have all the other columns, which gives us the detailed report. The gender, marital status, department, right? All the 29 columns. This will ensure that we don't miss out performing any step on the preliminary analysis step for your data. So univariate analysis is taken care of thanks to automated EDA library called SweetWiz. We do have other libraries which you can experiment on. AutoWiz, then we have Detail, Pandas Profile. These are some of the popularly used libraries. Now, by analyzing each and every report, we'll have to derive certain insights. But yeah, that's from the analytics perspective. Proceeding further, the manual EDA can also be implemented. The describe function will be giving us the descriptive statistic information for your first moment and second moment calculations, that is mean and standard deviation. Along with that, it also talks about the distribution of the data by capturing minimum, maximum, first quartile, third quartile, and as well as median. By analyzing this data, of course, describe function only works for numeric columns. That is something we need to remember. But it gives us the preliminary required calculations for analyzing the numeric data. We've already seen the data types using the info function previously, but we can also assess the same thing using data types here, df.data types. It gives us the same results where we will be able to assess the data types of the columns. Next, you can see isNull is a function which can identify if there are any null values in the data set. isNull is a function which verifies each and every cell of your data frame on whether there is any data or data is missing. And when we do sum on top of this check, it will give us the total count, where Python by default treats true as 1 and false as 0. So if there are any null values, then isNull function is going to return true in that particular cell. So that will be counted as 1. When you add, you will get the total number of null values for each column. And because the data that we have captured is from the HRIS system, and of course we have done primary data extraction, primary sources data extraction, we do not have any missing fields here. Moving on, there are certain columns which are not required for actually building the data, right? For model analysis. For example, employee ID is a nominal data. It's only used for identification. So we can drop that particular column. Similarly, attendance is the column which does not really have any variations. In our data set, we are looking at employees with 100% attendance. So there is no variation, and hence we can ignore that particular column as well. So we drop that column as well. Post which we try to look into the correlation between the fields using the correlation function. And we also had the heat map, which is probably not shown here in the code, but we had done heat map, which actually highlights which fields have high correlation. Now you might see that we talked about only 7 columns being numeric and remaining 22 columns being non-numeric. Correlation is giving the results, right? If you carefully observe the data types, you can see that the categorical data is also converted into numeric data points. So we used dummy variable creations to get the data into numeric fields. And then we did all these calibrations. So one label encoding was used for converting the data into numeric forms. That's a different discussion altogether, but yeah, we had to convert non-numeric data to do the calculations. Hence, we used label encoder to do that conversion. Then coming down, after correlation, we also had analyzed the performance rating department-wise. So we grouped the data with respect to the unique departments that we had in the organization. Every organization has a bunch of employees working in a specific department. So do we have any performance deviations with respect to departments wise, the entire department wise? So you can see that there's not much variation with respect to the aggregated performance of the departments. All the departments are almost same. Then we also looked at how many employees are there for each department. And you can see IT department has the majority of the employees in our data set. Then this number gives us the number of people, number of employees having a specific count, the performance rating. The majority of the employees have the performance rating as 6.3 on a scale of 10. We also see the majority is 7.8. That's the maximum rating that we can see here in our performance. 7.8 is the highest, and we had very less number of people getting those values. We can also do group by with respect to discretization can be implemented to see how many people are getting more than 7%, 7 as rating. How many people fall in a bracket of maybe 5 to 7, right? This kind of analysis can be further done. But yeah, this value underscore counts on performance rating gives us a quick look at sneak peek into the performance rating. We are not specifically looking at the employees who have greater than 7.8 rating, because very less number of people have that kind of a rating, and these could be treated as an exceptional cases. We categorized the data for numeric values and categorical variables, separated them. And then we have a bunch of functions performed on this particular data sets. Like what is the experience, how many values are there in each experience, how many departments are there. We also have seen the code for grouping the data with the department perspective. We also verified for the duplicates. So all this was part of the EDA that we have performed. We also had to verify whether the data falls normal distribution or not, specifically for the data which is continuous in nature. So we also used the probability plot check. Using probability plot, we checked whether the data follows normal distribution or not. There are a bunch of variables like overtime, job satisfaction, work-life balance, affected with corona or not, performance rating, and project evaluation. So we verified all of these are being normally distributed or not, and we can see that majority of data falls on that red line, which gives us an idea that the data is almost normally distributed. Then we also had done histogram, verified the box plots, bunch of various visualization techniques were used. This is part of the manual EDA work that we have done, along with SweetWiz. So SweetWiz is an automated technique, but all these steps that you're seeing is manual EDA tasks. We can scroll down and see all the visualizations here. This is the heat map. Because of the space constraint, you're not able to see the numbers appropriately, but when we visualize it, when we zoom it, we'll be able to see the numbers. Moving on, we had to take the data, divide the data into input features and output features. In total, we had 29 columns, out of which 2 columns were dropped. So we have 27 columns, starting index from 0 to 26. So we had considered all the rows and have taken the last column, which is the performance rating, which is in the index number 26, into output, and the remaining variables into input variables. And we also have considered only from the 6th column to 26th column or 25th column as input columns. Coming down, this is where the model development actually starts. Before we build the model, we needed to partition the data so that we can use the test data for evaluating the best model that we can obtain. So partitioning is done into 80-20 rule. Post that, we used linear regression, decision tree regressor, random forest regressor. We can also see support vector regressor. It's a black box technique. K-neighbors regressor, extreme gradient boosting regressor, and then bunch of metrics that are captured to evaluate the model. And you can see the next cell talks about aggregating the results. This cell is upfront executed to give you a comparison table. Of course, we have to actually develop the codes, the models, which is done in the next cells. Just to show you that these are the results. The R2 score that we are looking at here is, 99% if you see for linear regression. But at the same time, the mean square error is also something which is very low. We needed to be a little cognizant or careful with using this model because it is kind of overfitting. Among all this, we choose random forest model because it is more close to reality. There were other checks which were also considered. Right, overfitting and underfitting were problems that we had to take care of. So that's the comparison of the results, but these results are obtained when we develop the models. You can see in the cell number 25, the linear regression cell. This is the code, and you can see the R squared for training data and test data, which is too good to realize that the model is working. 99% accuracy. It cannot be used to generalize the problem. So when we added noise data and when we verified the model, it was failing drastically. So we couldn't use this very, very accurate model. Then decision tree model, decision tree regressor. And this is definitely overfitting. You can see train and test errors. The next model, support vector regressor. This is also too good to believe because the model is giving us close to 100% accuracy for both training and test. And when we used noise filled data, then right, the generalization was not done properly with respect to support vector regressor model as well. So we moved on to another model, which is K-NN regressor, K-NN neighbor technique. And this probably gave a better result for us, 92% and 89% respectively for train and test accuracies. Then extreme gradient boosting technique. It also had 94% and 92.6% accuracies respectively. And you can see the bunch of parameters that you can see in this particular code. This is based on your cross-validation scores that you can see, right? The 92% cross-validation scores. But the bunch of parameters that you're seeing are based on the hyperparameter tuning experimentations that was done offline, which is not shown in this code. Using grid search techniques, we have got the best model for regressor, the XGBoost regressor. The same thing goes for your other tree-based algorithms also. The hyperparameter tuning was done offline, and what you're seeing on the screen are the best models given the set of parameters that we pass to the models. Moving on, random forest regressor, 98% and 87% accuracy is something that you can see. And we use 1200 estimators, 1200 trees for your random forest model here. This is a very simple vanilla model that gave us good results. But the model did not improve much when we did various hyperparameter tuning solutions that we were applying. So we use the vanilla model as is. This experimentation, all the different models that we have tried, after we have chosen, we had to save the model. To save the model, we have used Pickle, and the demonstration that you are seeing here is for your saved model. In binary form, we use the open function to save the random forest model here into a Pickle file. We call that as model. You can see the Pickle file is dt_model.pkl. This model, the saved model, was used for deployment. So you can see the bunch of libraries that are used for deployment. We can scroll down. This is the code. Of course, you're not executing this code, but you can see the bunch of libraries: Keras, Pandas, Keras activation functions. Then we used Flask libraries. All these libraries are used to work on the saved model. Scroll down, and these are the input applications that we are passing to the model. And we are calling this function as app.run. The main function is triggering here. And when we execute this, we get the UI. We can go back to the UI, and this is the look and feel. We can go back to the screen, the input screen. This is the result screen. If I go back, this is basically how your deployed screen looks like. Again, this is only for demonstration purpose. You can see only few fields are being asked as an input, and the demonstration only shows manual entries, but we can also pass multiple fields or multiple employees details at one go in a CSV file or in a text file, and the model will be able to evaluate the performance of each and every employee and gives us the result in a table format. So this is the deployed solution, friends, and as you can see, we have used a simple library called Flask. The scope of improvement with respect to the model development, of course, goes into AI related fields like image processing, your text analytics, NLP related solutions can be implemented with respect to the feedback that the employee is given on quarterly and monthly nudges that the HR people do. So every month the feedback is collected, and a lot of text data is also being generated. So the scope, the enhancement of the project, you can see, is line in analyzing that textual data to include the sentiment analysis and various other aspects to capture the performance of the employee, the mindset basically of the employee, which is influencing the performance overall. Image processing also can be used when we are using these remote tracking, remote working employees tracking system. We can have the webcams and switched on to see the behavior of the employee, constantly monitor and see whether the employee is actually working or probably getting deviated from the work. So these are all part of the core, the product enhancements, which are probably part of another project discussion. So this is the employee performance prediction models that we have seen. As you can see, there are different models that were experimented. And finally, we have used Flask application to deploy it. Hope you have enjoyed the discussion and taken some cue with respect to the discussion with respect to this particular project, which is in the HR domain. We will meet again next week, and we will talk about a different use case coming from a different industry altogether. The sessions are to ensure that you all get the exposure on how analytics is being used in different industries and different projects. So hope you gain a lot of knowledge from these sessions, and until we connect next time, take care of yourself, and good luck, and thank you, friends.